Dear students, today I am discussing about the electrochemistry, the third chapter in the plus 2 chemistry. Electrochemistry is a branch of science that deals with the production of electricity by the spontaneous redox reactions and the use of electricity to undergo non-spontaneous chemical reactions. This topic is very relevant because it is used for the production of different types of metals and also for the production of different types of chemicals, for example sodium hydroxide, and different gases like chlorine gas, etc. And also it can be used for the production of different types of batteries, especially fuel cells, etc. Fuel cells are highly efficient and also pollution-free batteries. This electrochemistry mainly deals with the cells. There are two types of cells. One is electrochemical cell and the other one is electrolytic cell. First of all, we can discuss about the electrochemical cells or galvanic cells. An important example of galvanic cell is Daniell cell. Daniell cell consists of an anodic half cell and cathodic half cell. Anodic half cell consists of zinc electrode dipped in zinc sulfate solution. And the cathodic half cell consists of copper electrode dipped in copper sulfate solution. And these two half cells are externally connected through voltmeter. And the internal circuit is completed by using salt bridge. And this, as we know, this anode is usually undergoing oxidation reaction. Oxidation means removal of electrons or losing of electrons. So zinc is undergoing oxidation and it loses electrons. And copper is acting as a cathode and it is undergoing reduction. That means it is gaining electrons. So when this zinc is dipped in zinc sulfate solution, zinc undergoes oxidation and becomes zinc 2 plus ions and it goes to the solution. And the electrons that is removed from this anodic half cell goes externally and goes to the cathode, and the copper ions present in the copper sulfate solution gain those electrons and deposited as copper in the cathode. That means electrons are flowing from the anode to cathode. And we can draw the figure of this Daniell cell. That is galvanic cell. Its example is Daniell cell. In this, zinc electrode is acting as the anode and is dipped in zinc sulfate solution. The other half cell is copper electrode dipped in copper sulfate solution, and these two half cells are externally connected through voltmeter, and the internal circuit is completed by salt bridge. This is anode, zinc. This cathode, there is copper. Anode is negatively charged and cathode is positively charged. And this zinc electrode is dipped in zinc sulfate solution. Copper electrode is dipped in copper sulfate solution. Zinc acting as anode and is undergoing oxidation, and the half cell reaction of anode is zinc gives zinc 2 plus 2 electrons copper act as the cathode, and in the cathode reduction is occurring. That means Cu2 plus ions gains the electrons that is obtained from the anode and becomes copper and is deposited at the cathode. By adding these two equations, we are getting the net reaction, and the net reaction is Zn plus Cu2 plus gives Zn2 plus C. This is the net reaction. The function of the salt bridge is it provides electrical contact between two half cells. That means it completes the internal circuit. And the other function of the salt bridge is that it prevents the accumulation of electrical charges in the half cells. That means in the anode, as we already said, zinc is undergoing oxidation and becomes zinc 2 plus ions. And those zinc 2 plus ions are accumulated in the anodic half cell. And in the cathodic half cell, since Cu2 plus ions are gaining electrons and become Cu, SO4 2 minus ions are accumulated in the cathodic half cell. So when these ions are accumulated, this flow of electrons will be stopped after a while. So in order to prevent that, the salt bridge is functioning. That means salt bridge is an inverted U2 and consists of gelatin or agar-agar powder and is mixed with inert electrolytes like KCl or ammonium nitrate. For example, if KCl is present, this K plus ions can neutralize the SO4 2 minus ions in the cathodic half cell, and the SO4 2 minus ions, Cl minus ions of KCl can neutralize the zinc 2 plus ions accumulated in the anodic half cell. That means K plus can neutralize the SO4 2 minus ions of cathodic half cell, and the Cl minus ions can neutralize the excess of Zn2 plus ions in the anodic half cell. That it neutralizes the that is, it maintains the electrical neutrality of the half cells. Okay, so this is the Daniell cell, and Daniell cell that is an electrochemical cell. In this, electrical energy is produced by the spontaneous chemical reactions. This is a redox reaction. Why it is known as redox reaction? Because there is oxidation and reduction. Both are occurring. That is why I said an example for redox reaction. Then for the representation of this Daniell cell, if we are asked to represent the Daniell cell, there is no need for drawing this figure. Okay, so instead of that, we can represent the Daniell cell like this. That is, first of all, anode, then slash, then the ions present in the anodic half cell, then the double line that indicates the salt bridge, then the ions present in the cathodic half cell, then slash cathode. Okay. If we are given the concentrations of the electrolytes, that can be written in the brackets. For example, if the concentrations of the zinc sulfate and copper sulfate solutions are 1 molar, we can write it like this: 1 molar here, 1 molar here also. Okay. You have to note that this cathode is always represented on the right hand side and anode in the left hand side. Okay. While drawing this figure, when we are representing this cell, always represent cathode in the right hand side. Okay. The next is about the calculation of the cell potential. Before that we have to discuss about the electrode potential. What do you mean by electrode potential? Electrode potential means when a metal is in contact with its own ions, that develops some potential difference. So that potential difference is known as electrode potential. There may be losing of electrons or gaining of electrons. Losing of electrons means oxidation potential and gaining of electrons means reduction potential. An electrode can act as an anode or cathode. That depends upon the other half cell to which it is connected. So, a metal can act as anode or cathode. That means it can have oxidation potential or it can have reduction potential. Okay. So here in this Daniel cell, zinc is undergoing oxidation, so it is having oxidation potential. Copper is having reduction potential. According to IUPAC system, the reduction potential is considered as the electrode potential. So if we are just saying that electrode potential means there is a reduction potential. Okay, reduction potential means the potential that is developed by the gaining of electrons. Okay. So when metal is in contact with its own ions, there is maybe gaining of electrons or losing of electron. Losing of electrons means oxidation potential. Gaining of electrons means reduction potential. A metal can act as both cathode and anode. Okay, that is electrode potential. Electrode potential is developed in the anode and cathode. The difference in the electrode potentials is known as cell potential. So how we can represent the cell potential? Cell potential E cell equal to E cathode minus E anode. Cell potential means E cell equal to E cathode minus E anode. When we are representing this in the that is in the standard way, if the concentrations of the solutions are 1 molar, if any gaseous material is present, if its pressure is 1 atm, that is 1 atmosphere, and if the substances are very pure, we can say that electrode potential can also be called standard electrode potential. Standard electron potential can be represented by E0. So, then the standard cell potential E0 cell equal to E0 of cathode minus E0 of anode. E0 cell equal to E0 of cathode minus E0 of anode. Thus we can determine the standard cell potential. Okay.